Well, hello there. My name's Dean, and thank you for joining me today on my presentation about alignment angles. Today we're going to cover the three main alignment angles that we see on automobiles today, how we make those adjustments, and why those adjustments are important. I'm going to utilize my hands to help create gestures today to better communicate those alignment angles, and I think it's going to work out quite well as there is a lot of geometry involved, and it will help us with the visualization of this topic. Now let's get started with those three main alignment angles that we have. I'm going to start in the order in which we make our adjustments, and that would be with caster. Then I will talk about camber and toe. Caster is the angle running through our steering axis. So if you can visualize my thumb and my pinky as being connected to the control arms of the vehicle, and they are going to turn as I turn the wheel. My wheel would be mounted out here. Now with this angle, if I tip it back, I have positive caster. If I tip it away from the driver, that gives me negative caster. We can easily look at this as a motorcycle. Motorcycles have their suspension generally uncovered out there for everyone to see. Now you'll notice that if you go down from the handlebars on a motorcycle, it is raked forward out to the wheel. This helps give that motorcycle stability. Kind of the opposite of a shopping cart. If you've ever pushed a shopping cart through the store and you've got a front wheel that is going like this, we have a caster problem with that shopping cart. The next angle that we'll talk about is camber. Now we generally view camber as looking at the front of the vehicle. So if I'm your vehicle facing you, what are the top of my tires doing? Are the top of my tires tipped in? Do the top of my tires tip out? We refer to this as tipped in being negative camber, and tipped out is being positive camber. Now camber will affect our tire wear, and it will affect the handling of our vehicle. The next angle that we'll look at is toe. You could simply just look down at your feet and utilize that as our toe, right? So if our vehicle is toed in, then your toes or the tires are pointing in towards each other. If our vehicle is toed out, then your toes or the tire is facing out. So from the front of the tire to the back of the tire, we have more distance at the front than we do in the back. Vice versa on toed in. Closer distance on the front, further distance on the back. Now we adjust these angles with a computer-aided alignment machine. So most of these machines have a drive-on deck that you would go up. So we prefer to utilize two people in order to make these adjustments. One person would guide the driver onto that alignment rack or that deck because it's not very big, and if they were to turn off to the side, they would run the vehicle off of the alignment rack, and we would have some severe vehicle damage potentially from that. Once we get the vehicle situated properly on that alignment machine, we then have sensors that we will mount to the wheels. These come in two different forms, right? We have electronic ones that can daisy chain or connect together, and they communicate with each other and have sensors in each head essentially. Or more common now, we have mirrors. We would attach a set of mirrors to the two front tires. We attach a set of mirrors to the two back tires that are specific to each corner of the car. And then they would communicate with cameras mounted up on top of the machine in the front. Some of these machines have tracking cameras that will move up and down, so that way we can raise the vehicle to different heights. Some of them are stationary. It just depends on the model in which you have. Now, in order to make adjustments on the vehicles, we have a couple of different options depending on the make and model. One of the most common that we see today is eccentric cams. If you can just visualize a round bolt but make part of it flat, right? So our bolt's now a D-shaped, so to speak, and we can put an eccentric shaped cam on that that would be sort of egg-shaped, right? As we turn that bolt, that will then also turn that cam, right? And depending on which way I turn that cam, that will either slide my control arm in towards the center of the vehicle or push my control arm out, which then changes where that steering axis was at. So if I'm pushing my steering axis directly out, then I am changing my camber, correct? If I am utilizing that and it's pulling that steering axis back towards the driver, that is going to give more positive caster. Some other common methods that we have to make this adjustment with is shims, where we would simply loosen up our connecting bolts to our control arms, and we may have shims that will stack in place, or we may remove shims out. Obviously, stacking shims in, depending on the design, will increase the length of that control arm, and pulling shims out will decrease the length of that control arm. The third most popular adjustment that we see, or maybe even the most popular adjustment, depending on the alignment angle in which you are adjusting, is threaded rods. So if you just real quick think of that toe, right? A lot of our steering linkage has a threaded rod that is in there. And if we loosen up a jam nut on that threaded rod and then we spin that threaded rod, we can lengthen or shorten depending on which way we thread that rod. And that will, depending on if we're connected at the front or at the back of our steering knuckle, tow our vehicle out or tow our vehicle in. And these are just three simple methods that we have to make adjustments. We could get into some more critical alignment adjustments that are a lot less uncommon, but we will skip ahead instead to looking at why these adjustments are important. Now, that first angle that we talked about, that caster, not all that important for tire wear, but is important for us for directional stability of the vehicle. That caster angle is actually what returns the wheel after you turn a corner. When you go and turn a corner and you let go of the steering wheel, it generally turns itself back and positions you straight. We do not have to go hand over hand after we turn a corner to straighten our vehicle back out. That comes from that caster angle that is built into the vehicle. Now, if we move on to our camber angle, remember camber was tipped in or tipped out. That is a major tire wear angle for us and also will cause our vehicle to pull. Camber pulls to the more positive side. So if I had negative on this side and positive on this side, my vehicle is going to want to drive right off the road that direction. With that being said, if we look at that angle and the flatness of the road, I'm going to wear my tire on that inside edge if I have negative camber, because all of the weight will be coming right to the edge of that tire, wearing off just the inside edge of my tire. Moving on to toe, which was angled out or angled in, that is also a heavily wearing tire issue that we could see, and it will usually wear our tire in a jagged, or we call a stair-stepped or sawtooth pattern, so to speak, as we are skidding that tire down the road. Now, in order to get these angles set on the front of the car, we first need to set the thrust angle on the back of the car. So if you're visualing the geometric center line of your vehicle, we need to know where that rear axle is in relation to the center line of the car. Or we could just simply, if we had independent rear suspension, be looking at toe that is offset one direction or the other. If you've ever seen a vehicle that's skidding down the road kind of sideways, it looks like the driver might be looking out their window in order to drive straight down the road. They have a thrust angle problem with that vehicle. Thank you for joining me today. I hope you appreciated the hand gestures that I added to this video to help relate those suspension geometry from our alignment to you. Remember, always start with caster, then we change our camber, and then we set our vehicle toe. We must begin at the back of the vehicle and work our way towards the front in order to get our alignment set correctly. Thank you again, and have a great day.